that F is also 65, please.
Okay, so no, it may not be. It may not be. But if a line was drawn here, then this angle here would be the same as that angle. But it wasn't drawn. So I can't use that one to say the angle F is the same thing. Okay? So I had to use the opposite, the cyclic quad information from the cyclic quad, which says opposite angle in A of a cyclic quad are supplementary. Okay?
Yes, sir.
Okay. Now, so I have one, so I'm okay here. It's 124 degrees?
Yes, sir.
Yes, sir.
Okay, beautiful. Let's look at one more circle theorem before we start pushing into others. I hope that the person who really wanted me to go through and work the circle theorem question, that they are here. So I'm doing this final one now and see what it is. So we want to find x, y, z. X, y, z. So this is the angle we want to find. This angle here. So I'm going to give you 7 minutes on this, yeah? 7 minutes again. Last time I ended up cutting short, you know. And I will always do that depending on where you are, yes?
Excuse me, sir. Can you scroll up back to the previous question for a small moment?
Sure. Is that a small moment you need? I think you want to take a photograph, don't you?
Yes, I do.
That's fine?
Yes, sir. Thank you.
You're welcome. Somebody says that XYZ is 52 degrees. How did you get 52 degrees? Okay, cyclic quad rule. I agree with that somewhat. No, it's okay, Brianna. I just got this. I remember the time. I remember the time. Right. I'm sure people have finished already. Am I giving you guys too much time? Should I start? I think we can start now, yeah? Okay,
Yes,
so
sir.
for the first one, yes, XYZ, the angle would be 180 minus 64 degrees, because we're looking at a cyclic quad and we're saying that opposite angles of a cyclic quad is supplementary. That means you add to 180 degrees, okay? And so the solution to that would be 116 degrees, okay? And then we want YXZ. So where are we? YXZ. So it's this angle here. Ah, ha, ha, ah. Now the person asked me the question before about how the opposite angles in a segment is. This is an example, a typical example of it. Because here we want to find this angle here. But here we've got a segment inside here formed between the tangent and a chord. This angle here is in this segment down here. And the opposite segment to that, joining that chord, those angles are the same. So we would say that that angle is that 25? I think am I seeing right? 23 degrees. 23 degrees. Yes? Angles in the opposite segment. Yes? And OXZ, that's this angle here. What will that angle be? It values 3 marks.
26.
26? How did you get 26? Because we know that this is 128, yes?
Sir, what I didn't know, but yeah.
Yes? And then we've got to have the 6. You sure? So that's 120. What did I have here? 120? Let me make sure. I've got 1.
That's 128, sir.
Is this 128? Yes, twice that. So then we'll have 180 minus 128, and we're going to divide that by 2 because we are having an isosceles triangle. Okay? So that would be what? 52. So that's 52 divided by 2, which works out to be 26 degrees.
Sir?
Am I correct? Yes?
Yes. I don't understand how you get the Y.
Say that again.
I don't understand how you get the 23 or the YX.
How did I get it 23?
Yeah, I don't understand.
Okay, good. All right, let's zoom it up a bit. Okay? All right, what I'm saying to you is that this angle here, you notice this tangent? There is a chord that exists here. So this chord, the angle that is formed between the tangent and the chord, is equal to the angle that is in the opposite segment. So this is a chord here. In other words, any angle that is joining to that chord here over here would be equal to this angle over here. Okay? Is that clear?
Yes.
Sir, I get the 128.
Okay, 128 because the angle at the center, angle subtended at the center is twice the angle subtended at the circumference, sitting on the same chord. So you notice it sits on this chord here. It's sitting on that chord. Yes? So both angles are sitting on that chord. And because they are sitting on the chord, the same chord, one is at the center and one is at the circumference. The one at the center is twice the one at the circumference. Okay?
Okay, sir, thanks.
Sure, no worries. Okay, so I'm going to leave that circle theorem one out, and I'm
Excuse me, sir.
Say that again?
Sir, you never have another way to work out the YXZ.
The YXZ? Tell me now.
Now I'm asking, sir, because the way that you tell me is just not sticking in my brain, sir. So I'm asking if you have another way.
I agree.
Hey, listen to me. A Kingsley say no sticking in my brain?
Yes, sir.
Kingsley, go and get some thing of it. Some glue. Yeah, I'm going to make it stick in your brain. All right, let me show you something. Let me show you something, Kings. Everybody who is looking at it, yeah? I'm going to separate them. Yeah? That's a tangent, yes? Now, if I have a chord anywhere, yes, good. Now, look at what's going to happen from here now. Is that if I join anything joined to that chord there, this, that's a triangle that is formed, yes? Now, what I am saying to you is that this angle here, on the outside here, that is between the chord and the tangent, whatever angle that is there would be equal to this angle inside here. So because it's at, you see, one of the things we need to look at this. What does this do? What's this region known as? That's a segment, right?
Yes, sir.
So there is a segment that is formed here. Yes? And there is an alternate segment which is over here to this one. So there's an alternate segment over here. So the question is, or the statement is, that this angle here is equal to any angle that is formed over there sitting on this same chord. Do you see that? Maybe there's an easier way to explain this one.
Excuse me, sir. The two segments, like the one, the purple one, and the minor segment over the yellow one, sir, aren't they the same?
Second. So you're talking about this segment here, this angle here.
Sir.
So this is a segment, and that's another segment.
No, sir, I'm separating, sir. Like, go over the other side, sir.
Over here, sir?
The other side to that, sir.
Okay, so this side.
No, sir, the side like that, sir, but the other one to that.
This one?
Yes, sir. It looks similar to the one over there, sir.
Hey, don't look on looks, man, because we're not dealing with measurement, actual measurement. We are just saying to you that, yes, and you're correct in a certain extent if I understand what you're saying. This angle here would be equal to that angle there. You see that?
Yes, sir.
Yeah? So if that's what you're saying, then this angle over here would be equal to that angle there. And this angle here is equal to this one. All right? Can I go? Has it started sticking in?
Yes, sir.
Yeah, eat some cow foot later. Because you know that's sticky. No.
Go back up. I'd like to ask a question, please. Just
Sure.
1 2 seconds.
So the angle form at x, that would equal to the 23 degrees?
Angle form at x. Let me see what you're asking me. Okay, yes, with this green one. With this green.
Okay, sir. Thanks.
Yes. Yes.
So, sir, that means that the other angle would be 41, not true?
Which one?
The one to the other segment. Since over the other side would be 41, that means that the other one in this segment would be 41, right?
You're talking here 41?
Yes, sir.
But where did you get 40? Are you saying that this is 41?
Yes, sir.
How do you know that?
Sir, you have the 23.
Mm-hmm.
Then you have the 116.
116?
Yes, sir. And 23 plus 116, it gives you 139. And
Okay.
since all are supposed to equal 180, you get
So this
40.
we are saying that one is 41 degrees. And
Yes,
that
sir.
one is 23 degrees. And if you add them in that triangle, green triangle, it would give you what? 180 degrees. Good?
Yes, sir.
Yeah. I love the question and I love the idea that you guys don't want me to move on until you have a full understanding of it. And that's fine. Yeah. All right. So I'm skipping that one and I'm coming to this. We looked at this 2 weeks ago, yeah? Coordinate geometry. Was it last week or the week before? Not too sure, but it was coordinate geometry. Can I give you 2 minutes on this? Because time running down, you know.
Yes, sir.
2 minutes on that one. We have 7 minutes before and I have one more question that I really, really, really want you guys to know. Because somebody had mentioned, I promised that I would do a quadratic, another quadratic today. Okay? For those who are here, remember, we've got, what, how many minutes? We've got 6 more minutes and then the conceptual learning or teaching and learning will take place, in which we are looking at, today we'll be looking at bearings, area of triangle, and the rules, the sine and cosine rules. Okay, so we're going to spend some time working on those today. So we've got 5 more minutes before we enter into that section. All right, so here the question asks us to find the gradient, yes? And we remember that m is equal to what? y1 minus y2, the difference in y over the difference in x. Good? Now we can label this x1, y1, x2, y2. We don't necessarily need the labeling. Yeah, we just need to know that the difference in the y. So the y would be what? 3 minus 2 over negative 5 minus 1. Yes? So m would be what? 1 negative 1/6. Okay? Now, if we've got m as that, remember the formula we used? Y minus y1 is equal to m into x minus x1. Good? This works all the time. So we're going to have our y. select any of the points that you want to use, either A or B. Which one do you want to use?
B.
B. Okay, I know why you chose B. So it's going to be 2 is equal to negative 1/6 into x minus 1. Then we simplify. Y minus 2x is equal to negative 1/6 x plus 1/6. Yes? Oh, where did I get this x from? I don't know where this x come from. Yes? So I'm going to bring the 2 over. Or I can multiply through by 6. I don't know what's going to happen there. Let's multiply through by 6 right away. And I've got 6y minus 12 is equal to negative x plus 1. Bring the x over, so it's going to be x plus 6y is equal to negative, no, not negative, it's equal to 13. And that's a general form. If I wanted it in the gradient point form, when I go from there, I would have just simply say y is equal to negative 1/6 x plus 2 and 1/6, which is 13 over 6, okay? Yeah, don't need that. That's fine there. Okay? Good. Next 2 minutes, should I? Now we can approach some of these for next maths clinic when we have it. Since we've got 2 minutes, I don't want to go into any other time. All right, so 2 minutes to start. I want to welcome everyone who is here. Thank you for joining the Math Clinic section. Thank you for your participation in the Math Clinic here, in which you answered and asked questions for a better understanding. As you know, we've got 3 parts, in which the first part is a Math Clinic. The second part is a conceptual learning, which Dr. Barker will be leading. And then we get back and we will be looking at the consolidation section, in which we will be working through questions to consolidate what you have learned. Those of us who have not yet registered, I implore you, send me an email and get yourself registered. I'm sure you have received over the week, those of us who have registered have received your emails now. I know Dr. Barker insisted on making sure that everybody got their email this week, including myself. So I know that everybody got, and I'm at the bottom of the list. So if you haven't gotten your email, please make sure you get registered. And that's it. Basically, today I sent a message out that you have your calculators with you, as we will be looking at bearings. We'll be looking at the area of the non-right angle triangles, the non-right triangles. Maybe that's a cat. I don't know what's that's what we're going to work out with. And then we're looking at the non-right angle triangles using the sine and cosine rule with it. Dr. Barker, I know you're going to be embarking on the bearing, the bearings question. How can we use bearing in our everyday life? We're going to be using bearing. We're going to be using trigonometry and area of triangles. How is that outside of the exam? How can we locate that in our day-to-day life?
Yeah, I think that's a good question. Last week we talked about vectors, and the connection between vectors and bearings is quite clear, because we talked about vectors being used on ships, where vectors is distance and direction. to get a magnitude and direction. Well, bearing actually is where most of these ships use to determine their direction. So ships, airplanes, anything that's navigated in these open spaces, they need something to guide them. And so while they're using vectors, and they may use meters or kilometers to measure the distance, they will need a way in which to tell direction. And they do not necessarily use north, east, south, and west. They tend to use numbers to help them. And so the idea is to show you how that works.
Okay. So how will that link in with trigonometry? How does that link with trigonometry?
Well, again, trigonometry is highly practical. So, people have to make decisions and calculating and so on. So that knowledge will become useful as well. In terms
okay. So now it's your turn. So
it was here.
Take it over.
1 second.
Okay. All right, guys, thank you for sharing the information you shared with me from CSEC this week. What's going to happen is that Dr. Barker and I will look at the topics, if there's anything that needs jigging or rearranging, and we will make sure that we will continue to cover the syllabus as much as we possibly can, and then we will have, leading closer to the exam, we will have other sessions available for you.
Question, sir?
Yes.
Excuse me 1 minute.
Sure.
So the questions that you sent to our email, if we don't understand it, what are we supposed to do? Email it back to you, what we don't understand?
You could, or you could join here in the math clinic session that we had this morning and just say, sir, you send me an email to say, can we go through these? And I will go through them. Or if you send a message, I could just work it for you, and it may be a case in which you need that's all you needed for me to work it through for you.
Okay. All right, thank you.
Yes, and while we're at it, I just wanted to wish all the mothers
Yeah, I'm getting I don't know if my screen is showing, is it? Okay, so let me get to the correct space. Okay, so we just had a chat about bearings and the way that it can be applied, and you did ask about how that's connected to triangles and so on. So I suppose we'll do a little bit of that, and then we'll see some applications of that within exam questions. They start to see how those are connected to a ship goes from one place, and how far is it from the port, or an airplane, or people, or so on. So a lot of that will happen. But what I'll focus on is just the triangles and explain how those triangles can be solved, and the tricks, the ideas. And then after that, you will be able to ask questions as you see the exam questions. So let's see. We have done some work on trigonometry already. So this is not new. We did some work with using the so-called tower, working on right-angled triangles. So now this is the extension of that, where we move away from just right-angled triangles to any triangle. So today's work is really on any triangle. So I'll set the stage for that when we get to that. But the main thing is now we have covered the basics on right-angled triangle. We are now going to expand that onto all types of triangles. So hopefully that will be useful. It's 8:35. So I'll get started. So as I said before, our plan today is to get through bearings and then get through sine rule and cosine rule. And at some point, we'll also look at the sine error formula. Now, a lot of this work is for example, sine rule and cosine rule. These formulas are already given. So we don't need to memorize the formula. We just need to learn how to use them. So in your exam, those are given. All right, so what is a bearing? Now, I mentioned that when we talk about vectors last week, we talked about a vector having magnitude and direction. Now, magnitude is how far. So much that they're going 500 kilometers, that's how far. But for a ship or a plane or anyone else, they'll say, yeah, that is good to know, but what direction? So bearing is how these people navigate and use and connect the two. They'll say directions. But for us, when we talk about directions, we tend to talk about north, south, east, and west. And so we tend to focus on direction and maybe say it's going to the north or to the south, to the east, and to the west. And just if you didn't know that north, east, west, and south, if you look, that spell the word news, because in reality, that's where the word news come from, because it was information from north, east, west, and south. So that's where you see that coming from, and it's maybe a good thing to remember. So we tend to talk about direction in terms of what we call the cardinal points. But that is not enough, because between every cardinal point, there are a wide range of directions that people could travel. And in the real world, nobody is going north, east, west, and south all the time. They might be going in different directions. So we have to understand that in the real world, they have to have a better way of giving direction. In our normal little space of north, east, west, and south, that's okay. But in navigation, yeah. Let Morgan, he knows how. Yeah, so if you are ever on a ship, there's a machine that they use to do all of that, you know, but maybe nowadays they are using computers to do a lot of this. They'll type it in and digital, but in the past they used to have all of these machines that they used to set the bearing, and then they'll follow that using the ship, the big steering that you see they will have on ships. So, you know, it's something that is practical, but for your exam, you just need to understand how this relates to triangles, or it relates to getting new angles, and so on. So the first part, I'll just give you a basic idea of how bearing work, and I'll get into sine and cosine rule, and then you will be able to see what that's like in exam situations. So as I said, it's used to describe direction relative to north by using angles. So as I said, we have the north, east, west, and south, but there are other directions. If you ask people, they'll say, oh, I know these ones as well. So for example, if we're talking about the one here, you know, like this one, talking about this one or this one, we know that this would be northeast, you know. And then we might talk about this one, we'll say that is southeast. It's important to know these anyway. And then there's southwest, and there's northwest. But even when we cut the distances, the direction, we still have other directions in between. If you're studying subjects like geography and physics, you may find they talk about north, northwest, and north, northeast, and so on. But we won't get into that. We're going to apply this to how navigators take this from words or symbols like these into numbers. So they start off by thinking about the bearing as, say, north is the 0 point. So at all times, north is considered to be the 0 point. It's quite normal and logical to assume that as well, simply because it's at the top. So it's not something that is, say, difficult to comprehend, the idea that north is at the top and north is also 0. Now, how bearings work, it's always calculated from north, and we describe every other direction as if it is measured from north going in a clockwise direction. Now, what's a clockwise? We mean going towards the right. For people are like how the clock moves. Now, when you say clockwise, in the past, this was maybe something everyone would be familiar with. But nowadays, most watches maybe don't even have that. It's digital. So we'll see. But the idea is that clockwise is in that direction. So going towards the right. And all distances are described as such. For example, what we would normally call east is now, we say, at 90 degrees. So we think about 90 degrees from east, from north. This is 90 degrees from north. That angle between here and here is considered to be a 90-degree angle. If we go from here to south, we would need to turn through 180. All right, because we know that going all the way around is 360. So this is just basic idea. Likewise, going west would require us to turn a full 270 degrees. And then getting back to 0, 360 degrees is the same as going through start at being at north, because remember, it's not so much about the degree, it's a direction, but at 360, we are facing north anyway, so it doesn't matter. So in that sense, 0 and 360 will occupy the same position because they represent the same direction. Now, so you would see that, you know, the ones that we knew before, like northeast, these are equally spaced and they occupy these positions. Now, when we move from angles into bearings, bearing is what we call three-figure bearing. And when we are using bearings, we really don't need to use a degree, because we are now transferring this to bearing and using a three-figure format. So something like 45. So we'll see what happens. So obviously north is 0. We don't really need to write 0, 0, 0, but that's okay. But now if we look at east, we would have written it as 0, 9, 0. But that 9, 0 makes sense. That's 90 degrees. We have to have 3 figures. That's important. So we'll put that 0. There's no need for a degrees because now we're doing bearings. And we're just saying that 0, 9, 0, that's the bearing. And that's okay. 180 has 3 figures already. No need to add another one. So that still remains the same. 270 is still 270. But now we're measuring from north in this direction all the time. So now we'd say that west is on a bearing of 270 degrees. So if you're a ship and you wanted to go west, you wouldn't say to the person, go west. You'd say, move in a direction, or maybe let's travel in the direction of 270, a bearing of 270. We'd say something like that. We wouldn't say west. Because in most cases, they're not traveling exactly 270. They might be going 265, and that's when they need to be accurate. When they go on a bearing of 265 and for a distance of 127 kilometers. And that's what they would be doing in the ship. Likewise, 45 will become 045 or 045. 135 is okay, it's already 3 digits. So technically, anything lower than 100, you'll need to add on some zeros to make it up to 3 figures. That's really how the bearings work. All right? So the basic idea is that all the directions that we know can be described with a numerical value, and these are angular values in relation to 0 or north and measured clockwise. All right, I'll show you what I mean. Let's look at this example. So let's say we have a point A and another point B. Now, if you wanted to travel from A to B, all right, they would have to decide the distance and also the direction of A to B. So let's say that arrow represents the direction. And if we calculate the angle between A and B, if we measured from A, we'd do from north, measure that, and let's say we got 147. Based on what I've just said, because bearing is measured from north and going clockwise, what would be the bearing of B from A? Anyone knows? What would be the bearing of B if we were measuring it from A? Yes, it would just be, it's still 147 because the angle that is between them is 147. And if we had measured that angle from north and going clockwise, that is still 147. So the bearing in that sense is just that angle. There's nothing complicated in that. All right, let's look at another one. We have A, and we're going to measure the bearing of B from A. So A is where everything is happening. So at A, we need to have a north line. Let's see what information we have here. We have 227. That's the angle. What's the bearing of B from A? 227. So there's nothing complicated here. We just need the angle between north, going clockwise, all the way around to the direction that we want to travel it. So effectively, if they'd measure the angle, they'd turn the ship all the way around through this angle. And when they reach this point, 227 degrees, they just start traveling along this distance until they get to the point that they had set, maybe 50 kilometers away, 100 kilometers away. So that's how it would work. Let's look at another example. So the bearing of B from A is 227. Let's look at another one. So we have B and A, but this time I'm going to give you a different angle. Does anyone know what is the bearing of B from A? What's the bearing of B from A? All right. Okay, okay, so in reality, when we are doing 213, let's see. Okay, let's see why it is so. So remember, even though we are being given this angle, this does not represent the bearing. This just represents an angular value that we may have on a diagram. To find the bearing, we still need to know this angle, this one, the one that's traveling from north and going clockwise. It's a very simple concept to understand. So really, we are interested in that angle. That's the one we're interested in. Now, we know that there are 360 degrees in a full revolution. So we can use our basic idea and know that 360, take away the 147, will give us that 213. And that would be the bearing that we're looking for. So the bearing of B from A is 213. So don't let this angle fool you. I've just given you this angle. You need to now look and say, I really need this one. And whatever you need to do with your angle work to get there, you're going to have to do it. Now, I'm doing some easy ones, but you will have to remember the basic idea. You measure from north in a clockwise direction. If you do not have that value, then you do not have the bearing. There's no shortcut. So, like in this one, just remember, even though they give you this 147, you might think, I wonder if I go left, I call it negative. Technically, you could do that at a certain level, but in bearings, it's a positive number. And so we know what we're doing here. Let's look at another one. So we have B all the way here, and I'm going to give you this angle. It's 47. What's the bearing of B from A? $313. Let's see. Again, that's the angle we want, right? Starting from north and going clockwise. That's the angle we're looking for. And we know the whole thing is 360, so we can know the same. And we end up with 313 as our bearing. No, I haven't worked this one out, but what would be the bearing of A from B? Meaning we're working here. We want the angle from north coming all the way around to here. Anyone think they know what that angle would be? I'm not going to spend too much time on it because I haven't prepared this one, but I'm sure you'll have some example questions like this. Yeah? No, it wouldn't be 47 because we want, if we're starting from north, if we think about it, if north is all the way up here, yeah, this angle coming all the way around cannot be 47 because that's actually more than 90 to get from, if you're at B and you're trying to get to A. So I'll leave that one with you and think about that. But the bearing of A from B is not the same as the bearing of B from A or B from A from B. It's not the same. All right. Mr. William will have some examples that will test that kind of thinking, but just be mindful of that. That's something to bear in mind. All right. So bearings, as I said, it's just basically the basic idea is that moving from north in a clockwise direction. And once you have that basic idea, you'll be able to apply that into exam questions. Now, sometimes in exams, they may ask you to draw it. That's something I can't do with you because obviously we don't have those kind of opportunities to do that. So the basic idea is to remember that when you see something about going on a bearing of 27 degrees, you know it's starting from north, going clockwise, and you draw your line to match that. But that's something that may come up on exam questions, and you just have to practice in order to deal with those situations. I just wanted to share the basics because a lot of the questions that we do with sine and cosine rule will require you to have a basic knowledge of how bearings work. So that's bearings. All right, let's move on to triangles. Now, as I said before, the we have done some work on the right angle triangle, and I maybe wasn't nice to them. I called it the rats. Now, for you to do well in your exam, you will need to understand how to work on any triangle. So we're going to kind of ditch the idea of a right angle triangle and just say we're going to think about a general triangle. And that's just a polygon with 3 sides. There's nothing interesting about them. The sides doesn't have to be the same. They could be. The sides doesn't have to, we don't have to have equal sides, whether 2 of them are not, doesn't matter. It's just a triangle with just numbers and angles, and pretty much any ordinary triangle, a scaling triangle. But it could also be, it could be any triangle. But when I think about the general triangle, it's just any triangle. All triangles are included in what I'm going to say now. So the first thing that we know about a triangle is that it has vertex or vertices, right? As sides, and 3 sides meet. Where every 2 sides meet, there's a vertex, all right? So let's say our triangle is labeled A, B, and C. Now, at all times, when we label triangles, the capital letter is reserved for the angles. So when we talk about a capital B, we're talking about the angles. And you get used to what I mean as I do the other question. But something to bear in mind, capital letters are reserved for the angles and the vertex. You'll never normally see common letters outside of a triangle. You might see it on a side, but you won't see it outside. So the capital letters always represent the edges of the line segments that will then eventually form the sides of the triangle. Okay? So that's AB, that's BC, that's AC. We tend to say them in alphabetical order, but it doesn't really matter that much when we're talking about lengths. So capital letters are for angles. Now, common letters or lowercase letters are reserved for the sides, but they are not just randomly placed on the triangle. The common letters, the sides that have these names, have specific positioning. So for example, if we start at, say, angle A, the side that's directly opposite to angle A, so there's angle A here. If we have a side that's directly across from it, that side is labeled with the common letter A. It's just called A, all right? So when we talk about side A, we're talking about the side that's directly opposite from the angle A. Very important that you understand this terminology and how triangles work. Likewise, if we wanted the side that is opposite to B is called B, lowercase b, all right? And likewise, if we go to C, it makes sense now. The side that's opposite to C, lowercase c, is called C. So when we look at our triangle, that's 3 angles, 3 sides. If we know what the vertices are, we can automatically label the sides and know what they are, or vice versa. So that is important to know. Now, this is not restricted to triangles with ABC. I mean, if it's PQR, the same principle applies. Side opposite to R is R. The side opposite to Q is Q. And the side opposite to angle P is P. So it's just a matter of understanding a convention that we have with triangles, or any, well, triangles, how we label the side. So all the time you need to bear that in mind. If you don't, it can cost you as you work through. It's just convention. This is how it's done. This is how it works. But this is the understanding that the side opposite to the angle bears the name, but with a common letter or a lowercase letter. All right? So as I said, common letters are reserved for sides and capital letters are reserved for angles. All right? So bear that in mind. Now, we're going to spend some time doing the sine and cosine rule, and it's important that we understand this terminology and always be able to label the sides on a triangle. If you're having trouble doing that, you need to practice that until it makes sense to you, because this is something you have to know. Because now we're going to look at the sine and cosine rule, and those rules require you to understand this convention. All right? Now, I've just cut this from your exam paper. And these formulas are given, so you don't need to memorize them. They're always there, and you'll be able to use them. Now, the sine rule has three parts to it, but it really is never used. The three parts are never used. You really just use it, a part of it. It's just to say that the relationship exists across all three sides. But really, when we do the sine rule, we'll only use two parts of it. All right? Cosine rule has another version of this. I'll show you on one of my slides. But it's the same formula rearranged. All right, so let's have a look at an example. And here we have a triangle, and we're asked to find x. It's not a right angle triangle. All right, so we have, this is not a right angle triangle. It's a normal, just a scalene triangle. Anyone knows the size of this angle? Just for, because sometimes in the exam they'll say, what is angle P or Q? Anyone knows that angle? Yeah. How did you get 65? Who is that? Thanks. Okay, yeah, so the three angles must add up to 180. And so we do the work to do that. Now, sometimes this is the kind of stuff you need to keep always at your fingertips, those ideas, because they are useful in moving forward. So in this case, I haven't asked you to do that. We're asked to find the side X. Or in case of what we're doing, really the side Q. But normally in exams, they'll put an X or another letter on the side. So we're asked to find X. Now, what I'm going to encourage you to do is focus on what is given in the question. Now, you have the sine rule, you have the cosine rule. You need to learn to decide. You need to have a process in order to know which one to use. If you don't do that, you can start thinking, which one do I use? And you could use the wrong one. So what I'm going to walk you through is a process that allows you to know which one to use all the time. So you need to write down what is given. So we know that we have been given the angle P, which is 67 degrees. So I can write that down. I know that I'm using capital letters to represent the angle. So P is 67 degrees. We have also been given angle Q. When I say given, what is in the question? You're not working anything out. You're just looking at the question and saying, okay, they've given me angle P, they've given me angle Q. Have that. The other thing that they have given us is the side P. Because remember that the side opposite to the angle is going to be P. So they've given us P as well. P7. Now, a very important thing to realize now, if you notice, we have capital P and we have common P. I'm going to refer to that as a pair. Once you get the two of them together, capital P, common P, this is going to be the sine rule. This is how it works. So once you put the information down, you will see that connection all the time. You see P and P, sine rule. You don't have to even think twice. You have enough information for the sine rule. Because remember, the sine rule needs P over sine P. And that's all you really need to do this question. Just a pair. So once you read through, look at the question carefully and say what's given, meaning the information that's already in the question. P is 67, Q is 48. Oh, I got P now, 7. I have that pair that I need for this. And I know it's going to be sine rule. We're asked to find Q or X. Yeah. So what we're going to find is X. This is what we don't know. That's why I put that in red. But the rest of it, this information is given to us. The moment that's given and you saw you get that pair, sine rule. Stop right. You start working from there. So as you maybe what's your method? Tell me. Oh, okay. Well, okay. Well, I don't tell you that because it's a lot of people might not remember. But yes, that is also important, and we can check. It will tell you the different situations. What I would say is that it's maybe straightforward for you to just write down the information because you're going to need it. And then if you see that pair, it's there. But yes, I agree. There are other, like, angle with included angle and all these things. But there's a lot of pieces that sometimes can throw students off. That's why I just go look at the question, pick out the information, and then just look for it. But yes, that's another way. That's like the sentence for the description of the situation. That works as well. So the main thing is just to make sure you get that pair. Once you see that pair, you know it's sine rule. Remember, you don't need to spend time going, is it sine rule or is it cosine rule? You just need to know when it is the sine rule. Because if it is not the sine rule, it is going to be the cosine rule. This is how these things work. So once you know that it's a sine rule, use it. As usual, we'll state it. Even though the sine rule has A equals sine A equal B equals sine B equals C equals sine C over sine C over sine C, you don't really need to use the other part of it. You're never ever going to need to do the other part of it. You just need to take a combination of them. And whether it is A over sine A or B over sine B really doesn't matter. Because these are just general letters used for the ABC triangle. You're going to have to start thinking about and saying, okay, for this question, it is P over sine P and Q over sine Q. Because notice, that's the information I have here, which represents my first part. And we have Q, but we don't have the small q. So we just know that this is what we're going to use. So even though the formula is like this, it always makes sense to write it in such a way that you can then move to the next phase. So this is the same thing. The letters are just interchangeable based on your triangle. So P is 7, so we can put that in. Sine P, the angle is 67. Now remember, don't get confused. Angles, sine, cosine, tangent only work with angles. So don't get yourself confused at all. But we're replacing P, which we know already, to be 67 here. That's going to be equal to Q, which we don't know, over sine 48. All right, now we have two fractions, if we look at them as fractions, and we can use a cross multiplication procedure. So we can do 7 times sine 48, and that should be equal to Q times sine 67. And this is how we get rid of the fractions. It's a simple procedure. It's cross multiplication. I'll just go back to that again. We have two fractions like this, and we can just multiply the numerator of one by the denominator of the other. Write that as one product, and then we multiply the numerator and denominator of the other unused halves. You can see some connections here, like the work you did in matrices and so on. There's a lot of connections in maths. We need to find Q, so we're just going to have to divide by sine 67. All right, so I'm going to make a jump here. So Q is equal to 7 times sine 48 over sine 67. And from here, you don't need to memorize anything. You just need to use a calculator to work this out. And you can do that in one go, or you can do that in 2 steps. It doesn't matter to me. The main thing is you type that in the calculator and you should get 5.65. So using the sine rule, we have figured out the length of Q. All right. So remember, that's the basic sine rule. This is me putting in based on the triangle that I have and the information I've been given. I'm using this to determine that it's a sine rule, and then I'm just simplifying, and then I have to use cross multiplication to break these two fractions, and the rest of it is just calculating. Remember, you can divide, you can go in one go, or you can do it step by step, all up to you. Depending on your calculator as well. Here's another one. What information is given? Anyone want to help? Okay. Well, I don't know if there's you use a sine rule on the calculator. Just type it. 7 times sine 48 divided by sine 67. For some calculator, you might have to do 7 times 48 sine. This is something you're going to have to get. What you have to do is try to do it on your calculator. And if you don't get 5.65, then maybe that's when I could say you try something else. But I don't have your type of calculator in front of me, so it's going to be difficult for me to know how to help you with that. I just don't know how to help with that. You just have to type that in, and if you don't get 5.65, then you know that you've done it incorrectly. If you press sine 48 and equal, what do you get on your calculator? If you just type sine 48 equals, what do you get? Have we lost her? So then you multiply that by 7 and then divide by sine 67 and then see if you get the same answer. Yeah. Yeah, man. So you're okay. This is the answer. Yeah, just have to, one of the things you're going to have to get used to is how your calculator works. So that's how it works. You have to get used to using your calculator on this stuff. Some calculator you can type everything in one go and just press equal and it's perfect for that. So all depends. All right, let's look at another example. What information have I been given here? Anyone want to help? All right. So we get n. So I'll just go through because I maybe type it in there. But yes, n is 67, capital N. So W is 58, N is 66, as you said. And then I just need to see what else I've gotten. Small w, 13 centimeters. As I said before, once you see that happening, you don't have to think too much. It's sine rule. Does that make sense? So the moment you see that pair happening, side and angle, once you get a side and angle, the side and the angle together, sine rule. You don't have to spend any time checking whether it's any other rule. It's going to be the sine rule that will be used. That pair is the giveaway. All right? And that's all you have to do. And then you know it's a sine rule, and we know we're finding the other side, which is n, small n. So we can then go to our sine rule, which I said is going to be the same for every question. I am going to replace, to make it more specific to this question, but it's the same formula, just different letters replacing different letters. The order doesn't matter, but I tend to put the information I have first. So 13, which is W, over sine 58 is equal to N, which we don't know, over sine 66. Same situation. So the biggest decision you'll make is going to happen right here. The biggest decision you make is right here. Which rule to use? And as I said before, the moment you see this happening, you know which rule. That's the sine rule. That is the sign that it is a sine rule. Okay, some people say they need a sign. This is your sign. I got the pair, it's sine rule. Now here's the fun part of it. If you know when to use the sine rule every time, then any situation that is not the sine rule, you know it's going to be the cosine rule. And so you don't really have to learn both at the same time. Remember, the formula is given. It's just you making a decision which of the formulas to use. So you look for that pair and you go, there's my sine rule. All right? You're looking for that pair. All right? So we were here. And I've talked to you already. These questions don't really change very much. The procedure is going to be the same. We're going to have to use cross multiplication to break that. And then n times sine 58. Now we don't have fractions anymore. Just have a basic equation. We're going to divide by sine 58. So we do that. N is equal to 13 times sine 66 over sine 58. Again, type that in your calculator, check it. You should get 14.004 or 14.00 something. You should get that. I've just written that to 3 decimal places because I wanted to. Your exam will always specify. If it doesn't, then you have to follow the rules. I know when the time it used to set to 3 significant figures, so you need to know how to do those things. But in general, if you have wrote the question all the way to here, you have gotten most of the marks. And then here you'd maybe, if you're asked to do a degree of accuracy and you didn't do it correctly, you could lose a mark. So you need to learn how to write to the exact accuracy that the exam wants. Sometimes it doesn't matter, sometimes it does. This is 3 decimal places. All right. Okay, so that's sine rule again. So we're still searching for another situation. As soon as you see that situation, you know it's sine rule. Let's try again. So in this case, we're asked to find an angle. We're going to find this angle, finding angle V. We don't know what it is. What have we gotten? We know that T is 66. We know that V is this side, small v is 9.2, and we know that small t is 8.5. I'm looking at the information and I see my sign, so I know this is sine. I see the two things together, t and t. There's my sine rule. Okay? As I said, once you know it's a sine rule, you don't have to worry about any other rule. You just go to the sine rule. So we're trying to find v, or the measurement of that angle, which is x. Capital V. A over sine A is b over sine b. Replacing with what I have in my question, just because I can. You don't really have to, but it's good practice. So I rewrite the formula using the letters that are related to this triangle and to the information that I have been given. So replacing t, we know it's 8.5. We know angle t is 66. We know v is 9.2, but we don't know capital letter V, the angle. That was referred to as x in the question. So sine V, trying to find V. Again, we can still cross multiply, so 8.5 times sine V. Cross multiply 9.2 times sine 66. And we're going to divide by 8.5 to keep sine V by itself, right? Here we're going to have to do some calculations. So sine V will be 0.989. If you do the calculations, you will get those numbers. So you don't have to worry too much about being perfectly correct with that. And then, but it's not finished. What do we need to do next to find V? Find, exactly. So we need to find V. We need to find sine inverse of 0.989. And that's something, if you don't know what to do, you need to check inverse, second function, shift, whatever you need to do to get to that. It will give you the angle of. Now I'm saying there, you do sine inverse. There's a number of ways you do that. Your calculator will determine. You either see inverse, you either see second function, you might see shift. Yeah? Whichever way, that's the way you do it to get that function sine to the -1. And that's how you turn this back into the angle. So, no, I think whenever it's shift, you have to do shift sign. 0.989. No, 0.989. Yeah, you see that. So put 0.989 equals. So how we get to 1.5? Okay. Maybe you type something incorrect. Maybe 998 or something like that. Got it now? Okay, good. All right, let's carry on. So this, in this example, we're trying to find an angle. And this is where the small twist in that one, where you have to find an angle. Let's carry on. Here we have another situation. Let's see what we have been given. So you see, I'm looking at every triangle in the same way. I'm just going, what have I been given? And I'm not interested in whether it looks like sine rule, looks like cosine rule. No, I'm just going, here's a triangle, what information I've been given. So let's see what we have been given. We know that T is 66. We know that u is 8.5, okay, that's this side. And we get v is 9.2. Now, do I have a pair? No, there's no pair. We don't have any, all the information I've been given is just different letters. Do you see that? So I know that this is not the sine rule. Yeah? And if it's not the sine rule, it's going to be the cosine rule. Yeah? So the other way to look at the cosine rule as well is if all of the information that we have been given, there are different letters. See? T, U, V. Cosine rule. So this is a cosine rule question. It's not sine rule. If it was sine rule, we would have to be given a pair of information. Hope that makes sense to you. So we know this is going to be cosine rule. Remember, the trick in exam is knowing which rule to use. So the key thing is knowing which rule to use, not what the rule is. Because the rule is given in the exam already. You don't have to study the formula. You just need to know which one to use. So once you're given the information, you need to look at the question and saying, what information is given? I have the pair, so I know this is sine rule. In this one, I've not been given a pair. I know it's not the sine rule. So I know it's the cosine rule. Okay? Somebody need to close. Tisha and Gianna. Okay, thank you. Let's get back. So we know it's a cosine rule, all right? And we're finding x. So we know it's a cosine rule. Let's have a look. This is the formula. We don't have to study the formula. We just need to learn how to use the formula. The formula is given in the exam. So it's not something you need to sit there and study. It's just given to you. So you just need to learn how to use it. Now, as usual, the formula is given with an ABC triangle in mind. What I'd recommend is always looking at this and trying to apply the letters that we have into that formula. So we're trying to find t squared, trying to find t. So effectively, we are going to replace everything else with the letters that would. So A, in this case, represents my t. So notice I've replaced those. And then the other letters are just repeated like that. It's not really a complicated formula because you add in the squares of the other ones and then you're multiplying them together. The only time A is seen in this formula is at the start and at the end, where we have A squared and then the capital A. The formula is given. No need to stress learning the formula. The key thing is to learn how to use the formula. All right? And if you're interested, I have a proof of this formula on YouTube. You can find it and watch it if you want to. I don't think you need to. So we have the letters, we can replace them. We have U, we have V. Notice we have U and V, and we have cosine T. We have the angle T. So we're just going to replace that. So I've just put them in one go. We can just check. 8.5 squared, 9.2 squared, 2 times 8.5 times 9.2 times cos 66. My recommendation is you just type this straight in your calculator and press equal. That's my recommendation. There's no need for you to do this step by step because it only increases the chance that you may make an error. The moment you substitute everything into this, you have already earned the mark for your method and accurate method step. The next mark is going to be for getting to the answer. So you just don't need to show any, you just need to type this exact same equation into your calculator and press equal. So if you do that, you'll end up with 93.2764, going on. No need. I just stopped at 4 decimal places. So you don't need to be doing 8.5 squared, then 9.2 squared, then no. That's only increasing the chance you may make an error. Once you have written this down, or in fact, once you have chosen the correct rule and made this substitution, you have gotten most of the marks already. And now you're just going to move towards finding the value of t. So we have t squared is 93.2764. How do we find t from here? All right. And we just get the positive square root, okay? So square root of 93.2764, and we should get 9.66 to 2 decimal places. So that's a cosine rule. As I said, you've been given the formula. You just need to learn when do I use each of them. If you get the pair of information, capital letter and common letter, that's a pair, that's your sine, and that's the sine rule. Okay? It says, show me a sign. So if you want like a rainbow, your sign. Once you see that sign that you have that pair, you're good to go. If you see different letters, technically, you know, this is now going to be the other rule, which is the cosine rule. Don't use the wrong rule, that's all. Let's have a look at another one. Someone mentioned two sides and the angle between them. That's one thing you'll see in textbooks, two sides and the angle between them. Problem is sometimes students know that, but they don't apply it properly. Yeah, so that's why I give you a little way of just writing down the information given. N, K, and M. Again, we don't have a pair, so we know this is cosine rule. Okay, trying to find N. So just notice how we get to that. We don't have a pair. If you look, we have three different letters, so we know it's not sine rule. That's important to understand the way that a math person thinks about this. It's not sine rule, so it must be cosine rule. All right? That's a cosine rule. That's it in what it looks like in the exam booklet. This is what it looks like when you put in your own letters. Remember, N, N, trying to find N, that's why. So it will always be N squared. If you write X squared, it doesn't matter either. MK, MK. You'll get used to it. Sub, just put in the information in. It's an easier question because don't even have decimals in it. 12 squared plus 7 squared minus 2 times 12 times 7 times cos 48. Again, as I mentioned before, don't try to work these out step by step. Just put them in your calculator. Pretty much every calculator can handle this. 12 squared plus 7 squared minus 2 times 12 times 7 times cos 48. Just put that straight in and press equal. And you should get 80.586. And now we know that when we have t squared, our next step is to find t by finding the square root. Okay? But t, sorry, yeah, true. It should be n squared. I can fix that. All right? It should be n squared. That's just me messing that up. So I'll just fix that quickly. It should be n squared. And that should be n. And that should be n. Okay. Thanks for spotting that. So n squared equals, so we find the square root of n squared of 80.586. And if you do that on your calculator, you'll get 8.98, almost 9. 2 decimal places. Again, the choice for me is that, remember, I am just picking my degree of accuracy. In your exam, it will state the degree of accuracy. Yeah, so you need to get used to doing that. Again, it's the same procedure. The biggest decision is which rule. The rest of it is calculator work. Which rule? And that's why I've given you that approach to it. Put the information that's given, look to see if you find a pair. If there's no pair, it's cosine. All right? In this case, let's, whoa. No problem. Okay, thank you very much. You're so nice. All right, so next one. Let's see what information we have been given. Now, in this one, you'll see this this symbol, it's a Greek letter called theta. It's a very common symbol that's used to represent a missing angle. You get used to it. It's just like X. It doesn't mean anything. But in math, you'll see this a lot as a way of representing a missing angle. So theta. But you can just treat it like any letter that is being used in this space. But theta is how we represent missing angles for the most part. So let's see what we've been given. We have given small p, agreed, 11. We've been given small t, which is 12. It's the length of the other side. I've been given small r, which is 7. So again, we do not have a pair, just different letters. So we know this is cosine rule. No need to worry about which one I had not lost. No, it's not sine rule. So it's cosine rule. But we're trying to find an angle because we've been given the 3 sides of the triangle. And we're asked to find the angle P. Let's go to the formula. Now, what's going to happen here, I'm going to write a different version of the quadratic formula. Now, this is also given. So in the quadratic formula, sorry, why did I say quadratic? Sorry, sine rule. What you'll find is that if you're given 3 sides and asked to find an angle, this is the one you use. All right. You can use the other one. Don't get me wrong, but you have to do a lot of transposition to get it right. You can use the other one, the one like this one. Let me just go back to that. You can use it in the same way. Just replace everything. The difference is you'd put something here and nothing here. And you'd have to work it backwards, solve the problem backwards. It's a little bit tricky because you could make a mistake. So it's not a case where it's a new formula. It's the same formula, but transposed, reorganized for your advantage. So cos A, again, this is given to you. Formula is given to you in the exam, so you just need to know when to use it. If you're given 3 sides and asked to find an angle. I'm going to replace cos P. Notice that A is here and A is at the minus A squared, so we know the rest of it is just the others in normal positions. Minus A squared, A. So obviously I'm going to try and copy that onto the other one. So T squared plus R squared minus P squared over 2TR. So now we have replaced the formula in the structure that with the letters that we know. And then we just need to replace them with the information that we have taken out. Just replace everywhere. 12 squared plus 7 squared minus 11 squared, all over 2 times 12 times 7. If we simplify, we get 72 for the top, and the bottom we get 168. Okay. And then we can simplify it, divide it down, because we're going to use the cos inverse function, like the sine inverse function, to find the value of the angle. And here, I expect that you'd be able to eventually navigate to 64.6 degrees, to 1 decimal place. Any questions? Yes, you could. You could as well. So it all depends on how confident you are. You can just type that straight in. In fact, some people could type all of this in one go and say P equals, and they're done as well with the cosine inverse. But all depends on how confident you are on your calculator and know how to do it. So yes, you could go straight to here rather than make it a decimal. And that's more accurate as well. Okay? Yeah. Yeah, listening. Why it is the inverse? Okay. All right, the reason is, you see, we have cosine P equals 0.429. There's no, you see, this is a function, and in everything we do with functions, to undo them, we have to do what we call the inverse. So if you had something multiplied by something, to get rid of it, you'd have to divide. Division is the inverse of multiplication. Or if something is being added, to get rid of it, you could subtract it. So if you have +2, -2 makes it 0. So technically, the idea of an inverse is always there. Now, these functions don't operate like, the ones that we do. Their inverse function is complex as well. So we just need to know when to find the inverse function. So we want to get P by itself, so we find the inverse of cos. And that's how we end up with that. So it's just a function, and that's how you deal with those functions. Sine, cosine, tangent, that's how we do inverse of them. And it's a function that's on the calculator, so you don't need to know how to get there. All right, so that's how we get to that. And as I said before, you look at the triangle, get what you're given, and if you have a pair, then you know it's sine. If you're not, you know it's cosine. And you can try that. You'll find that it's as good as what someone else said earlier, like saying two sides and the included angle, or 3 sides. Those kind of things works as well for me. But I found that when I tell students to just write down what they've given in the question, they are able to make better decisions, because if you don't have a pair, you don't have the sign. Simple. It's not that there's nothing, and then you know what to do. And if you have a pair, you know it's sine, so you know what to do. All right. Yep. This one? Okay, well, if you don't see it, then you need to study this one then, yeah? Or you can practice doing the other one using the numbers without this formula. Just put the numbers in and see if you know how to work it to get 64.6. So you can practice with that other formula as well, if you're not. But you can just study this one and see it. I thought they had given this one, but maybe they haven't. I'm not sure. I'll double check. All right, Mr. Fullerton. All right, I'll hand you over to those people.
Right angle triangle. So it's important that we understand the information that is given. And at the same time, we need to remember, those of us who have not revised your angle work, you may need to do some revision on angle work so that you can master this concept, because it's actually a combination of the different areas that will come in. So let's look at this first question, and I'll see if I can work this through for you and with you. It says the diagram below not drawn to scale, and that's awesome when they say not drawn to scale, so you can't put a protractor to it. Shows a relative position of 3 fishing boats, K, L, and M. So these are fishing boats. L is on a bearing of 0.40 degrees from K. So in other words, they are telling me that here, from K, from reference point from, this is 40 degrees. But because it's on a bearing of 0.40 degrees, so I can either put the angle there or I put the bearing. Yes, depending on what you are asked. Yes, and what it is required of you. And from K and M is due south of L. So let's add something here to say that there is a north there because there's a south down there. And they say that LM is 120 kilometers, which is along here, 120 kilometers, and KL is 80 kilometers. It says on the diagram, show the bearing of 0, 40. Now it asks for the bearing. So once they ask for the bearing, I can't put this angle there. Yes, so that's my bearing that they ask us for. Okay, now the second part of the question, so I've done that, I can tick that off. The second part of the question says calculate the measure of KLM. So what I want to find out is KLM. That's the angle I need to find.
Sir,
Now, yes, there.
the bearing is 0, 40. Should it be in the inside or the outside? I just did it like that because I don't have any space.
I left it there because I didn't have any. Because it's a bearing. It's a bearing, so I have it like that. Yes? So from north in a clockwise direction, that's 0, 40 degrees. Okay?
So it should be on the outside.
Yes. I write it on the
Okay.
outside. I've always written it on the outside. It never dawned on me before. But I've always written it on the outside. Okay? And the reason I put it on the outside will become apparent with the next question, next part of the question. Yes?
Okay.
Calculate the measure of KLM, which is here, this angle here.
So can we use Z angles or alternate angles to say that it's also
Beautiful.
40?
Beautiful. Well done, Britannia. Miss Britannia Jones. Yes? That was an awesome response. Yes? You've said that I can use. So you're transferring your knowledge from angles to the alternate angles that is here.
Sir, how much marks number 2 were?
I'm not sure. I don't remember. I don't remember. I didn't have it on. I don't know why it's not there. I removed it because of the spacing. I'd cut the spacing out because there was working space there for you guys. Sorry. Maybe about 2 marks or maybe 1. 2. 2 marks maybe. Okay? So we would use alternate angle to say that it is 40 degrees.
2 marks.
Yes?
Okay.
So I know that this is 40 degrees from the alternate angles, knowing that we've got a pair of parallel lines and a transversal that goes through it. So this is a pair of parallel lines, and there is a transversal that goes through. So once you've got that transversal that takes you through, you've got the alternate angles that are there. Okay?
Sir, couldn't you also use the cosine rule?
The cosine rule? No, because let's find out. Let's find out. What are we given?
2 sides.
2 sides and ask to find the angle.
Yes, so all we're given were 2 sides to find an angle. Can we use that? See, Deandra says that we need all 3 sides in order to find the angle. Yes? So in this case, it wouldn't. Yes? Now, the next part says calculate the length of KM. So now we're going to find KM, which is this length. We need to find the length here.
Now we can use the cosine rule.
So now we can use the cosine rule, Miss Henley. So you're correct there. Good. And the cosine rule states what? We don't need to know it, but in this case, because we are working the problem, we need to know what it is. Yes? So in this case, we're going to say L square is equal to M square plus K square, yes, minus
2 times M times K
times M times K, yes,
cosine
cosine
L
L. Good. So let's do some substitution now. Yes. So we've got the L square is what we want to find is equal to M square, which is 80 meters square. So I'm going to say 80 square plus here I'm going to say now it is 120 square minus 2 times 80 times 120, the cos of 40 degrees.
40 degrees.
Yeah. And for me, if you put that all in the calculator, you could find L is equal to the square root of everything there. And you put that in your calculator. I have to go according to you because I don't have a calculator here. So tell me what you get for your answers. Yes, what's the calculation? Did you say 35 kilometers? Oh, the final, okay. No, somebody says no. So what is it then?
So I got 78.
78?
Yeah,
So 78 is the answer then.
78.05 to this decimal place.
But it says to the nearest kilometers.
Oh, 78, sir.
So it's 78 kilometers. Okay. And then the final one, so it says here 78. Good. And then the final part says calculate the measure of angle LKM. LKM. So we want to find this angle here. So now, you remember what Dr. Barker says to us? That we need a pair, don't? If we're
yes, sir.
Pair, so in this case, we're given a pair. We're given L and L, and we're given K to find angle K. Yes? So I'm working with angles. So because we're working with angles, I wasn't sure if Dr. Barker showed you this, showed it to you like this, because I want to find the angle. I'm going to put the angle at the top. So I want to find the sine K over 120 is equal to sine 40 over 78. Yes? And so I would then work this to give me sine K is equal to 120 sine 40 over 78. And you can put this in your calculator as a sine inverse of 120 sine 40 over 78. And what's your answer there? Any
So
solutions?
why did it like that?
Say that again.
Why did it like that?
You guys can, you remember Dr. Barker says you can work it out, you know. you can work it out and put the values in. But because I don't have any calculators, I just keep writing the value out. Is that what you're asking me?
Yes, I understand the same.
Pardon?
Yes, I understand what you're saying.
Okay.
So I got 81 degrees.
Sorry, what did you say?
I got 81 degrees.
81 degrees. Okay. So you're saying that this angle here is 81 degrees. Now it says calculate the bearing of M from K.
Excuse me, sir. When
Of
I round
M.
off, I get 82.
Okay, so when you rounded it off, rounded it up, and you get 82. Shall we work with 82 to say that level of accuracy, since it says to the nearest degree? So we've got here 82 degrees. And this would be 82 degrees. Now, it says calculate the
Yeah, it could have
bearing.
been 82.
What is it? 81 point what?
0.4546.
Was it 0.4? Well, let's work it as though we had all put the accuracy in. Did you put your answer in like this to get the accuracy?
Yes, sir.
And what did you get?
81.4567.
Okay, so it's gonna be 81 then, as was stated first. All right. So it's important, you know. That is important when we're talking about the accuracy. 81. It says calculate the bearing of M from K. So here is M, and that's K. So here we've got 81 degrees there from K, from our reference point. And our reference point, our north, is going to be here. Yes? Bearing is measured in a clockwise direction. Yes? From north in a clockwise direction. Okay? So what we would need to have here is 40 plus 81, which is 121 degrees. So the bearing would be 121 degrees. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Let's have a look at the second one now. So you see what we did just now? Look at this one question that came in. This one question came in, it brought in the bearing, it brought in cosine rule, and it brought in the sine rule. So all three came in. And there are times you will have all four of it inside there. So it's just applying the skills that you have just learned and that using the concepts that you had learned in previous lessons as well to bring across here. So let's look at this one now. I think you are about to make some solo flights, yes? Because today a lot of you will be preparing your preparing meals for your mothers, yes? Sometimes it's the first time you're going to cook and she's going to taste it and say yes, even though it may or may not taste as well as her face is saying yes, I'm happy. But I'm going to give you a solo flight here now, 5 minutes. And let us see if at the end I will have a smile on my face to say I am happy or not. I want to say, yes, a lot of burnt food, yeah? No worries. The mothers are going to say it's flavor today. I want to say welcome to those who are in Trinidad as well. If I've got any Trinidadians in the house today, welcome. Any Portlanders today?
Yes, sir.
Oh, anybody from St. Thomas?
Yes, sir.
Oh, wow. That's going well, man. Anybody from Westmoreland? Westmoreland silent. Dr. Barker, we need somebody from Westmoreland next time. Oh, I heard, I saw that. Big up the Trins. The Trin is land of the best doubles. Yeah. All right, time running. 3 minutes. Let's see what's happening here. No, we're not on a break. We're supposed to be working. Yes, I'm giving you a time to work. Come on. That's a method I do every week. Every week we come here, we try something for yourself. Because that's after this is where it's safe to make any errors that you're going to be making. You don't want to make any later on in the closer to the exam. So you want to stick to that. Who's going to help me with this one? Someone is saying confident. Okay. Who's helping me to solve this one? Anybody? Your time is up. Nobody has a confidence yet? Come on. Who is that?
So I think I got it.
All right, Daniel. Let's work with you, Daniel. Daniel, is that Hibbs?
Hibs, sir.
Hibs. Okay, go ahead.
So first I use the cosine rule to find the angle IP.
Are you doing part one?
Yes, sir.
Okay. It says a bearing of P from Q. So this is our reference point, yes?
Yes, sir.
So what they're asking you is to find that angle there.
Yes. Yes, sir. That's what I plan to do, sir. But my procedure is really long.
Okay.
So I don't try to find the angle I, and I just don't use the plus with the 45, the 54, I mean.
But did you realize, Daniel, that this information was given to you? That R is 100 kilometers from Q on a bearing of 066. So they're saying that here is 066 degrees to this point here. Did you see that?
No, I didn't read it.
Yeah, it's important that you read that, okay? So in other words, that bearing of P from Q would be all of this. That would be the 66 plus the 54.
Yes, sir.
Okay? And 66 plus 54 would, I think that would be 120 degrees.
Yes,
Last
sir.
time I checked. So the bearing of P from Q would be 120 degrees. Okay? So the second part now says that the distance PR to 2 decimal places. So we want to find this distance here. Now, what you will notice is that here, as Dr. Barker says, you won't be given any 3. Once you're using this triangle here, you don't get a pair here. So if we don't get a pair, we're going to use which of the rules?
Cosine.
The cosine rule. Okay?
Cosine.
And the cosine rule, I'm just going to work it like this, saying that it's PR squared is equal to 100 square plus 80 square minus 2 times 100 times 80 cos 54 degrees. Am I right? No?
Yes.
Yes, I agree.
Did I make too much of a big jump for you?
No, sir.
Anybody? Is that okay?
Yes, sir.
Okay, once everybody is okay, I don't need to take my time to take it too easy there. Right? No, I need you to put that in your calculators and work that out for me. Because we're going to find what now? The square root of 100 square minus 80 square. No, not minus. Why am I saying minus? Plus 80 square minus 2 times 100 times 80 cos 54. What did we get? And it says the 2 decimal places, yes? Did we get 83.464?
Yes, sir.
Yes,
Yes,
sir.
sir.
Are you saying yes or because I wrote it, or are you saying yes because you found it?
Sir, how did
Sir,
you get the bearing?
The bearing. The bearing I got from here. So I got this angle here plus this angle there.
Sir, I'm talking the 0.66.
It was stated.
It was stated in the question here.
Oh, okay.
Okay. Then it says we're to calculate the measure of QPR to the nearest degree. QPR. So we're finding this angle now. So once we're finding that angle, we now have a pair, don't we? So we can use the sine rule now because we are given a pair. So we are going to say sine P over 100 is equal to 54. No. What's missing? Yeah, we just worked it out. 54 is equal to sine 54 degrees over 83.64. We just worked that this is 83.64. Good? So we know that sine P is equal to 100 sine 54 over 83.64. In my sense, I would normally say P is equal to, so I wouldn't do sine P is equal to, I would say P is equal to sine inverse of that. Yes? So if I do my shift sign, and then I put my fraction in, and I would say, put my bracket in, and I say 100 sine 54 over 83.64. What did we get as our angle?
75.
75, but it says to the nearest degree, so it's 75 degrees. Okay, so angle P is equal to 75 degrees.
Sir, can I please scroll up back to the top?
Yes, I will. Is that okay?
So, sir, is one part alone? Oh, you did get the 66, sir.
Listen to me. You know what the problem is? You guys not reading the question. That's the problem.
Oh, there it is. Okay.
There, it's right there. So we have to read the question carefully to get these things out, okay? That's important. Because you notice it's about 4 people asking me that same question, based on the fact that you have not read the question carefully. Okay? So, the next question now, I want you to read it carefully. And again, you will notice that we did bearings, we use this cosine rule, and we use the sine rule in this, okay? This one doesn't have a bearing. I don't think this one has bearing, but this one has a little more than that. It has the area now. So area came into this one. Yes. So it says 2 marks. I should just give you 2 minutes, but I know it's gonna take you a little more than that. So I did put the information.
So you can zoom in it, please.
Sorry?
You can zoom in on it, please.
I didn't get that.
Oh, you can zoom in on it?
Yes, man. Like that?
Okay, thank you. Yes, sir.
But Daniel, you could zoom in on it with your gadget, though.
No, sir, the laptop I'm using.
Okay, sorry. All right, I'm going to give you 5 minutes. So as soon as you finish the second question, because there's one here, yeah? And then there's another one here. But read the question carefully, guys. Read it carefully, please. Daniel, which school do you attend?
Sir Calabar.
Oh, you're a C-bar man. Okay.
Yes, sir.
Sir, could you go back to the last one that we did for a minute, please?
Why, Miss Headley?
Sir, I want to look at it for a minute.
Quickly, Miss Headley, because others are working other questions.
Yes, so you can scroll back down now.
Okay. Next year, we'll put on a food clinic for all those who have the food interfering with them, yeah?
It sounds to me like it's not a clinic, people, it's a hospital. And I want it for wards. Accounting ward, food ward. It's a clinic, it's just one it's just one place, you know. It's not a hospital.
So, Dr. Mark, I realize that the education task force need to have a hospital now.
Yeah, a clinic now,
with the different clinics.
Yeah, man. All kind of ward required. So.
All right, let's push on with this one now. What we have here is this question requesting to find the value of QS, but I'm not going to do what you guys do. Just jump to the question working. It says on the diagram below, not drawn to scale. Yes, it says that is that RQ? RQ is 9 meters. RS is 12 meters. ST is 13 meters. QRS is 60 degrees. That's here. And SQT is 40 degrees. So that's that angle there. Okay? It says calculate correct to 1 decimal place the length of QS. In this case, the information wasn't hidden up there, so they placed everything on the diagram. So QS is what we want to find, which is this distance here. Yes. Now, if you check it out, if you check what's given, we realize that there's no pair. Yes, there's no pair given. So since there are no pairs, we can find QS to be equal to say QS squared is equal to 9 squared plus 12 squared, yes, minus 2 times 9 times 12 cos 60 degrees. Am I right or am I right? Yes?
Right.
Right.
So QS, I'm going to say put that all in your calculator. What did you come out with?
10.8.
Sorry?
10.8.
10.8. Beautiful. It says to 1 decimal place, 12.8 meters. Okay? Then it asks us to find the measure of QTS. QTS. So that's this angle we need to find. But we have just found this, so it is 10.8 meters. So I'd slip that in. And right away you realize now that we've got a pair that we need to we've got a pair there. We were given a pair. So we are working with pairs. Yes, opposites. So what we can do now, we know now that we are using the sine rule. Okay? And the sine rule then, I'm going to say, because we're finding angles, I'm going to say the sine of, is that R? It's T. T, yes. The sine of T over 10.8 is equal to the sine of 40 over 13. Good? So, because I am working with you guys and I know you understand this, I'm going to say T is equal to the sine inverse of 10.8 sine 40 over 13. Did I make too much of a big jump for you?
Yes, sir.
Yes?
Yes.
All right, let me take time with the jump then, all right?
Yes, sir.
I have sine T is equal to 10.8 sine 40 over 13. Is that okay?
Yes, sir.
Good. And then you would move to this stage. Okay? So what I want you to do now, put all of this in your calculator and give me an answer. What was the value for T? Did I say 32.3 there? Is that correct? Britannia?
Yes, sir.
Yes, sir.
Yes, sir. It's correct.
Yes, sir.
Good. All right. Now the next part of the question says, what should we do here? We should find the area of the triangle QRS. Where is it now? QRS. QRS is this triangle here. What's the formula?
Sir, half base times height.
That is the rat. That's with the rat. When it's not the rat, it is what? Half AB sine C, yes? So remember, it's the angle that is in between. So we're looking at these two sides here, yes? So it's half of, is that 12? 12 times 9 sine 60 degrees, yes? And what's that solution there for area? Anybody? Somebody wants to remember what, you guys forget what the rat means. Rat means what? Right angle triangle. Yes? So what's the area? Did you say 46?
46.
46.8.
Square units, square meters, yes? Because it's in meters, so it's square units, okay?
Excuse me, sir.
Yes, yeah.
Sir, like how we find the length QS, sir, could we also use the other formula, sir, where you have the square root of S, bracket S minus A, bracket S minus B, bracket S minus C?
Oh, you're talking about the other formula in which we could use half the semi-perimeter, in which we're using that. But yeah, we could have. We could have. But wouldn't that be a longer formula to use?
Yes, sir.
Yeah, we could have. And since we've got the angle, and the angle is between both sides, we could use that, yes? But well done. Is that Tracy? Tracy James?
Trish.
Well done. Well done, Tracy.
It was Trish, sir.
It was Trish? Ah,
Yes.
Trish, what's your last name, Trish?
Gooden.
Trish Gooden.
Yes, sir.
And
Yes.
which school?
What school is that, Trish?
Knox.
Knox.
Yes,
Oh,
sir.
my word. Is that Knox in Spalding?
Yes, sir.
Fear place them there, sir.
Okay. All right. And the final part now it says, calculate the perpendicular distance from Q to RS. Oh my word. Q to RS. The perpendicular distance. Let me drop that in. Q to RS. So somebody said earlier on, so this is what we are trying to find. This height here. The height here. This is what we want to find at H. Can somebody tell me how to do that? Because it says a perpendicular distance. Now, you notice that right away the rat comes in. Yes? So this question is bringing in a rat. Because now we've got a right angle triangle there. Now, because there's not enough space, it says calculate the perpendicular distance. I am going to try and do it like that because somebody says that they can't see. Yeah. What I'm going to do now is do the calculations here. So if I draw that triangle for you or redraw that triangle or make a sketch of it, that's 9 there. I've got, is that Q there? Q, R. Let's put something here and call this F. It wasn't there, but because it's at this point here, we're putting F there. But we want to find H. But we know that this is 60 degrees. Yes? So here what's happening now? With the right angle triangle, we need to say sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? So what are we looking at? First of all, we identify that there is a hypotenuse of 9. So let's cross out the hypotenuse. Yes? And what are we trying to find? We're trying to find H, which is the opposite. Opposite. So right away, we know that the ratio we are going to use is a sine ratio. So we say sine 60 degrees is equal to opposite, which is H, over 9. Is that meters? So H then is equal to 9 sine 60 degrees. And what's the value of H?
7.8.
7.8 meters. Okay, guys? Are we comfortable with that?
Yes, sir.
Yes, sir.
Sir, can you go over that back for me, please?
Okay. Say that again. You want me to go over it?
Yes, sir.
Okay. So what you notice here that we had a triangle. Yes? A right angle triangle because they asked us to draw a perpendicular from Q to meet RS. Good? So what I did was to redraw that, just taking out this portion here alone, which is a right angle of 60 degrees and 9 meters. 9 meters there. And we want to find the length QF, which is just the height, the perpendicular height that we are talking about. So we looked at it, examined our triangle, and we realized that we were given, it's a rat. So the moment it's a rat, we're going to write our ratios out. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. After we have done that, we identify the different parts. The parts that we identify was the hypotenuse. So we cross the hypotenuse out, which is in those two. Then we recognize that the height is being asked of us, which is the opposite to the angle that is given. So the opposite side is given. Because we've got two strokes, we're going to use the sine ratio. And the sine ratio is opposite over hypotenuse. So we substitute. So the sine of 60 degrees is equal to the opposite, which is h, which is unknown, over the hypotenuse, which is 9 meters. Yes? So we wanted to make h the subject of the formula. So we multiply both sides by 9 meters. So we end up with h is equal to 9 sine 60 degrees. Yes? And we simplify that. We place this in our calculator, and the end product is 7.8 meters. That clear?
Yes, sir. Thank you.
You are welcome. Final one. I think this may be the final one. Before I send you off to prepare your mother's meal, or send you to collect your meal from your children who have been slaving in the kitchen all morning. Okay? So read the question carefully again. The diagram below, not drawn to scale, shows the position of 3 points P, Q, and R on a horizontal plane. Remember, we discussed what the horizontal plane is. It's just a flat surface that has 3 points on it. Yes? Then it says that we should calculate, no? Yes, it says PQ is 120, which is there. It says PR is 150, which is there. It says angle QPR is 23 degrees, which is there. It says calculate correct to 1 decimal place the distance of QR. So I'm going to give you not a lot of time. Yes, I'm going to give you 5 minutes, even though it's a 9-minute question. You can see that it is a lot of time there, but I'm going to give you 5 minutes to start working, and then I will come.
Well, why do you think that is? I mean, why is that?
Sorry. Deandra, are you going to work this question for us? It is so. I love this question. This question is so awesome. Really, really love this question. Especially the second part. Or the third part, this part here. Okay. Deandra, you're still with us? You're helping us now? Ready?
Yes, sir.
Right. Good. So we want to find the distance QR. Talk to me. What are you using and why?
Okay, so I use the cosine rule, right? The a square equal b square thingy.
Yes.
Because we're finding a side and we'll have an angle being sandwiched by two other sides.
Okay. So you're saying that QR squared is equal to, talk to me, I'm writing.
PQ squared plus, yes, plus the 150 square.
Come on, I'm listening.
2 times 120 times 150 times cos 23. And then for that, I got 3761.8253. And then 3761.8253. And then the square root of that is 61.3 kilometers.
Beautiful. Everybody got that?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
that was part A. Part B says you should calculate the area. Ah, you sleeping on me, Britannia? No? So you want help? No, not Deandra. Let me write down Deandra.
Sir, what you saying?
Are you sleeping on me?
I'm not waiting for something. I should do B too.
Yeah.
Okay. So PQR. Would use the half times A times B times sine C because this is not a rat.
Okay, good. So we're going to find half of 120 times 150. And we're going to do sine. Where am I writing? Sine 23 degrees. What do we get there? Anybody?
I got 3516.6 kilometer square.
So 3516.6 square kilometers.
Yes, sir.
Everybody with her?
Yes, sir.
Yes, sir.
Yes, sir. I sound like if you guys afraid to tell her, say Anna, so like Anna see anything gonna get.
Yes, sir. We are with her. Yes.
Okay, all right.
Sir, question, sir. One, how do you know which sides are A and B?
It doesn't matter. It really doesn't matter. If you're talking about which is A and which is B, it doesn't matter. You could have used that as A, or you could have used that. Because it's multiplying, yes? It doesn't matter. 2 times 3 is the same thing as 3 times 2, isn't it?
Yes, sir, but
Yes, sir.
you can't use like the size for QR.
Oh no.
Like you don't use
how do you know? Because it is sandwiched between the angle. The two sides or the angle is sandwiched between the two sides.
Also, you use the length of the angles of the sides That's sandwich angle.
Yes.
All right. Thanks.
Okay. Is that clear?
Yes, sir.
That's CLEON. And your last name is JARDINE?
Yes, sir.
Okay, and you're from?
Guyana.
Guyana. I'm sure I'm not spelling this right, but I will know it's Guyana. Oh, so welcome to the Guyana crew as well. We didn't know that they were here with us. Bearings. This one is gonna kill us if you don't know what you're on about.
Mr. Fullerton, this maths class gone to the world.
Yes, but which is good. This question, who wants to approach this part of the question for me?
Sir, can I approach it?
Who's that?
Brianna.
Okay, Brianna, go.
Okay, so what I did was, I subtracted 108 from 180.
Tell me what you're saying. You subtracted 180 from what?
108 from 180.
Why?
So let me just look back one more time. Because it said P from Q, it is 252. So what you're gonna do is subtract 360.
Which is this?
252 from 360, yes sir. Which will give you 108.
So you're saying that here is 108.
Yes sir, and then you're gonna subtract 108 from 180.
Okay.
Which is 72.
So you get this angle to be 72 degrees.
No, sir. Yeah, you can say that. Yeah.
It's just here is 72 degrees, so you know.
Yeah, yes, sir. And you're gonna add that with the 23, which will give you 95 degrees.
Why would I add it to the 23?
Because aren't you finding?
So you're
the R from P. Yeah.
So you're talking about your alternate angles here.
Yes, sir.
So you're saying that here is 73 degrees.
72.
Sorry, 72 degrees. Okay. And you're adding 72 to 23 to give me 95 degrees.
Yes, sir.
Okay. Let me ask you a question. Yes?
Yes,
do you realize that the question says to us that we are finding Q from P is, this bearing here is 273. That's 252 degrees. That's a bearing. And they're asking you to calculate the bearing of R from P. Yes? Do you realize that you could have used, in figuring this out, this angle out, you could say 252 minus 180 degrees because it is more than. It was more than 180. You could subtract 180 from it. And you would have gotten the same 72 that way. Did you realize that, Brian?
Hold on, sir, I didn't see that all of you were going too fast. So do that one more time, please.
Okay. So you've got an angle here. That's a bearing. So if you're calculating the back bearing, so if we want to find that angle there, we subtract, because this bearing is 252, which is more than 180. If we take away 180 from it, we get the back bearing. So if I have my 252 minus my 180, do you not get 72 degrees? You didn't realize that, did you?
So you have to analyze this one, sir. Hold on. I have to process this.
All right, but that's it. That's it. You learned it last week, and that's fine. That's fine. Well done, Brianna. Good. Thank you for your attempt. That's correct. Yes.
Excuse me, sir.
Yes.
Could you go over that, please?
Which one?
Finding the bearing. I was lost.
Okay. All right. Which one do you want me to use? Brianna's method that she used.
No, use the 252 and then subtract it from.
Okay. So remember, if we've got a bearing.
Wait, sir. Why wouldn't you subtract it from 360? 10.6.
That's what I'm gonna say to you. Yes.
Okay.
If you've got a point M and you've got N, yes, and you've got these bearings, and let's say this bearing is 060 degrees. Yes, that's N from M. Yes, the from point is here. No. If I want to find this bearing here, which is a bearing of M from N, yes, what I need to do is to add 180 degrees to this value because this value is less than 180. So if it is less than 180, I'm going to add 180 to it. If it is more than 100, and so if I added it, because it's like this, because the alternate angle there is there, it's 60 degrees there. Yes, see that alternate angle? Plus this is 180 degrees. So 180 plus 60 would give you the back bearing. And that's exactly what she did here. Yes? But she did it differently. She did this subtraction and then take it away. She could have done it this way too. 256, 252, and then she take away this 100 and 80 out of it to get 72 there. So it works in both cases. Okay? Okay, guys? Thank you.
Yes, sir.
Thank you for being here. We are here every week. It has always been a pleasure to be here with you guys. We will be here until the exam. I think the exam is late. Is it late June? Yeah, late June. The 23rd of June. And we will continue to work with you, continue to go through the syllabus. And we are here at 11 o'clock your time in the mornings. Sometimes a little earlier, because when I log on, if I have more than 10 kids who log on at that time, we start the math clinic. Then we'll have the conceptual learning, and then we have the consolidation, which you have here. Yes? So thank you for being here. Thank you for your participation. Welcome to the Guyanese. The Ghanaians. The Ghanaians. Yeah? I think that's what they're. Yeah.
Guyanese, sir.
It's Guyanese? All right, let's work with Guyanese today. Yes? Welcome today. I didn't know you were here. I know the Trinidadians are here, Jamaicans are here. And we're here next week. Dr. Barker and I.
Sir, where you come from?
Where? What do you mean where we come from?
Which country?
I'm from Jamaica.
Sir.
Yes.
Suppose you're not as fast as everyone else, but you will like extra teaching. Do you offer that, sir?
What I will no, to be honest, we can accommodate you because I realize that we are thinking about this now. Dr. Barker, you can help me as to split the team, get the team additional parts, team members to be here to help us out, and we'll have different classes based on your needs. Yes.
Okay,
so
sir.
if that's your request, send me a message. If that's your belief that we are going too fast, or if we're going too fast, tell us. Yes? Were you okay, Miss Bowman, today? Were you comfortable going through the questions today, Miss Bowman?
Yes. I'm not fully clear on it, but I'm okay.
Yeah. But if you, yes, so what we do, we are here next week to help you consolidate again, as we have done today. And we'll always be here to just consolidating the work. So you'll see next week, I'm here with other questions of this type, going through and practicing. So if you are here every week, then you will become as quick as others. So don't worry, we'll continue to work with you. And then we will be having choices later on. Okay?
Yes, sir.
Okay.
Sir, do you have advanced classes?
Pardon?
Do you have advanced classes?
We haven't had the what we say, the clientele as yet. But we do, Dr. Barker and I are capable of doing that. So if the needs arise where our A-level students are needs, we can assist in that area as well. And members of our team can do the same. Okay? So if it's a need for you guys, let us know and we'll see how we can help you. Thank you and see you next week at 11 o'clock Jamaican time. Now I don't know if we've got other times lower down in the, if the time shift later on down in on the latitude, but we'll be here Jamaican time 11 o'clock to assist you and work with you. All right?
Okay, thank you.
Okay, have a lovely.
Which topic are you doing next week?
Dr. Barker, what topic we doing next week? Have we decided it? Listen, we will let you know. By Tuesday, you will know. Once you're registered, we will send the bulletin out to you, and once we send the bulletin to you, you will have that information. Okay?
Yes, sir.
Okay. All right. See you guys next week. And any question, just drop us an email and we will answer your questions as.
All right.
Yeah. Okay, bye-bye. Kingsley, you were quiet this week. Didn't hear much of you this week, Kingsley.
Sure.
Yes, General.
So, Mr. Daniel.
Yes, Daniel.
So, I sent you 2 emails already, so asking to be registered, but you never respond.
When did you do that? You
So I
was
think
one.
so it was a week before, I think, and the other one was, I don't remember, but I know I sent it 2.
Wait, hold on. That can't be right, man. That can't be right.
So I don't know if I have the wrong email.
You may have, because I think I respond to all the emails that comes in. Let's see what's happening here. You wanna drop the email that you have in the chat box so that I can see, please?
Yes, sir.
All is well?
Not yet. Yes, but I'm just working with one student here. Daniel, what's the email address, Daniel?
So I'm sending it now.
Because I don't remember receiving an email and not responding to it. No. Do you have my email address?
So the JMED one.
Say it again?
So the JMED one?
Yes.
Yes, sir. That's what I use.
And you send it to Daniel. You said Daniel. All right, let me see if I can search for you in this. I don't. No. Daniel. No, Daniel. I don't get any email from you.
Oh, so I probably using the wrong email for you then.
Yes.
I probably mixed up a little.
Let me send you the email address at gmail.com. Please send it to that email address.
Yes. So you want my number to, right?
No. Just send that email and I will send all the details to you. Yes? And then you will register. You'll add yourself to the WhatsApp group from the link. I'll send you a link to add yourself. Okay? And register to the classroom and everything. Okay?
Yes, sir. Okay, thank you, sir.
No worries at all. So, Barker, what's up? No, say I sleep for me, you know what? Barker. Miguel.
Yeah.
Yeah, the sleep.
What's that?
Yeah, say if I sleep, I sleep.
That me what to do now, yes.
Yeah, man, I work here tomorrow. I'm gonna love Monday, you know.
Yeah, no. These people sign in and just go on their business.
And they just sometimes they just get up for our own, so.